Hello everyone, welcome to RN Tutorials. So in this video in of engineering mechanics, we are going to discuss another problem for finding the center of gravity. Another example problem. So here we need to find out the center of gravity of 100 mm by 50 mm by 15 mm channel section. So that is the C section. We are going to find out the center of gravity for that C section. Okay. So it is similar to the method of finding the centroid as it coincides with the center of gravity already we know. And next this is the C section I want to assume. So according to the dimensions given. So here again we know that this C section is symmetrical about x-axis. So y component is 0. So here we need to find out what is the x coordinate value. Okay. So I want to represent the dimensions, that is the height is given as 100 and the width is given as 50 and the width thickness of the web is given as 15 mm. So this is the size of the C channel is given in the problem. So for this C channel we need to find out what is the center of gravity. So that is which is symmetrical about x-axis, so we need to find out the x coordinate only. Okay, so for that I want to give the name first: A, B, C, D, E, F, G, H, I, J. So before going to find out the final coordinate, that is the x coordinate for the center of gravity, we need to divide the each part as two different areas. Okay, so those different areas I want to represent with different colors. Okay, here the three different parts I have considered. For these three basic parts, so we can know the center of gravity position. So by finding the center of gravity of these simple three parts, we can find out the center of gravity of the whole C channel. Okay, so first I want to take the area ABCE, so which is the top part. Okay, that is the top flange ABCE. So for this area, first I want to write what is the area A1. Okay, area is equal to length into breadth, so which is 50 into 15. The length is 50 and the height, that is the breadth, we can consider as a 15. So 50 into 15 will give you the area of that flange, top flange, 750 mm square. So next again I want to write the x coordinate position. Okay, now x coordinate position assume, so the y axis is lying here. So from this left last part, so what is the distance in x direction for the center of gravity of this ABC means what is the total length is 50. So the half of the distance, half of the length of this rectangle will give you the center of gravity position for this ABC part. Okay, so that can be written as x1 is equal to, we can write it as 50 by 2, which will give you the center of gravity position for this ABCE part in x direction. Okay, so in the middle of this part we'll be having the center of gravity for this ABCE part. Similarly, I want to select the another part as DEFG. So for this rectangle, that is web part, we need to write what is the area A2 I want to assume. So A2 is equal to again height into width. So the height is 100 minus 30, total 100 minus this is 15 and this is 15, total 30. We have to subtract. So 100 minus 30 will give you the height of the web into width is 15. So finally we will be getting 1050 mm square as the area of the web part, that is EDGF or DEFG. And I want to write what is the x2 position. So again x direction, that is the x coordinate, that is the center of gravity of this web part in x direction, exactly the middle means the width is 15. So 15 by 2 will give you the center of gravity position for the next part, second part, that is DEFG, that is 7.5 mm. Okay, so next I want to consider the last part, which is FHIJ. So for this also I want to write the area as 50 into 15. Okay, same value will be getting 750 mm square. Similarly, x coordinate, that is the center of gravity of this FHIJ, which is equal to half of this total distance 50. Okay, 50 by 2 will give you the center of gravity position for the last part FHIJ. Okay, so after knowing all this A1 x1 A2 x2 A3 x3, we can substitute all the values in the equation, that is in area method. We already know that x bar is equal to A1 x1 plus A2 x2 plus A3 x3 divided by sum of the areas A1 plus A2 plus A3. So substitute all the values here. 750 into 25 plus 1050 into 7.5 plus 750 into 25 divided by sum of all the areas. So by using the calc, simplify this equation, automatically we will be getting the x coordinate value, which is 17.5 mm, which is the center of gravity position for the C channel on the x-axis from this web part where we are considering the y-axis it is lying. So that we can represent on the diagram also. Okay, so assume this is the point from this last web part we got, which is at a distance of 17.8 mm. So we can represent on the diagram like this, at which the center of gravity of the C channel will be lying, that is away from the solid part on the x-axis, because it is symmetrical with x-axis. So this is another example for finding the center of gravity of the C channel. Okay, I hope you understand the area method, which is used to find out the centroid as well as the center of gravity. So once again, thanks for watching my video. Thank you all. If you still have any doubts, please feel free to give a comment on my video. If there is anything wrong, please mention that wrong, so that I can clarify and I can improve my explanation in the further videos. And once again, thank you all.